This video describes how to use measure commands to find the corners of the Bode plot, and then how to sweep a capacitor value to get a more specific corner. So first of all, here is a inverting op-amp configuration. The first thing we want to do is to be able to create the AC sweep. So you're going to come in here, and under the functions you need to make sure that you have a small signal amplitude. So we're going to put in a voltage of 1 and a phase of 0. And then you're going to click up here to get the AC sweep. We're going from 1 hertz up to 100 kilohertz, and then we run that, and you see here is the Bode plot. We don't need the phase, so we're going to right click on this and don't plot the phase. So we're trying to find, this is the low corner and this is the high corner, and the low corner is when we hit that 3 dB point. So what we need to do is set up a dot measure command. So the first thing that we're going to do is we're going to come in and do a dot measure. We need an AC. We're trying to find this maximum point right here. So you're doing maximum, and we want the V of out, and we're just doing magnitude because we don't care about the phase. We just want to find the amplitude of that peak. So I'm going to put that down here, and then we run this, and you see that it has a maximum of about 20 dB. Since we did magnitude, there's no angle on it. So now the next thing that we need to do is we need to calculate the low corner. So here, what we're doing is we're calculating the F low, and we're calculating this value when the magnitude of the output is equal to this variable G max divided by the square root of 2. So this right here is basically finding out when we cross the 1 over square root of 2 point. And we put on cross 1 because you see when we're going along, I'm going to get cross here, and I'm going to get across there. So the cross 1 is going to be the low corner, the cross 2 is going to be the high corner. So this high corner one's going to be pretty much the same. We're going to call it the high corner, and this one's just going to be when we do cross 2. So then we run this, and you see that we use this, and when we did this, you notice that we're calculating it when. So we're using when this happens, we're going to grab the value of the x-axis, which happens to be frequency. So this is my magnitude. When the magnitude equals this is going to be at a frequency of 15.88 hertz for the low corner, and the high corner is at 13 kilohertz. Once we have these measurements, then we can come in and sweep a variable. So we're going to come in here and call this, put it in brackets, and we're going to call it C value. And then we're going to come down here and do a dot step param. We're changing the C value from 1 nano to 10 nano in 0.1 nano steps. And then we put this down here, and we run this. And so you see we're changing the upper corner, so it's plotting all of these different values. I do Control L to pull up this, and then I can right click and say plot the stepped parameters. Oh, there's lots of different functions that we have. So we come up here, and we're trying to find the high corner, so we do F high. And then this is the corner frequency as a function of capacitance. We're looking, let's say, for 10 kilohertz. So I'm going to go right there. You see this hits 10 kilohertz at 1.4 nano. So I'm going to come in here to check it and make this 1.4 nanofarads. We don't need this anymore, so we just make this a comment, and we run this. And you see we're at 10 kilohertz. And that's how we do it.